Um, Hi, I'm Simone Scarazza. I come from Teramo, Abruzzo, the center of the Italy, and it's a pleasure for me to be here. Thank you for your invitation. And today I'm going to talk about my study, where I focus on the possibility to employ process and algorithm in computer graphic for sound synthesis. Si sente? Aspetta, I take this. Okay. Wow. Okay. In these days, one of the drawing techniques which is becoming more and more interesting is parametric design. The software supporting parametric design allow to represent and produce models that, thanks to the synchronism of the parameters, they can be modified as unique elements. With this, the software supporting parametric designs allow to, for example, it's possible the use of routines to automate specific operation, or it's also possible to realize generative algorithm to create complex graphic elements. Basically, you didn't design the form, you designed the process to generate the form. Actually, to implement parametric design as a technique of sound synthesis, we need to realize or think the graphic elements inside a unit square. Unit square is a square whose sides have length 1. In this way, with some simple operation, we can size the graphic elements according to the note events of the score in C sound. With this, all elements inside the square can be considered as a unique model. We can stretch. We can change the bandwidth or the central frequency. Now I'm going to show a simple algorithm in C sound that will generate the graphic element. In order to understand the generative process, for me it's useful to start from a graphic model. Let's see. For example, this is an example. There are a series of glissando, and every signals start from the same point, have the same duration, and each segment has an increase of glissando of a certain step respect to the previous one. What do we have here? Allora, let's start from the end. Allora, in the note event, we have on P5 the minimum frequency we want. On P6 the bandwidth that is this. In P7 the number of segments. The program is based on 2 instruments. Instrument 1 generates the control parameters for instrument 2 that contains synthesis algorithm. very simple synthesis algorithm. In instrument 1, it has been implemented the loop, which we iterate. This is the loop, and which will be iterated n times the number of request segments P7. See, okay. For each iteration of the loop, the program calculates the new finite frequency, this. Also, you can see the mouse, the arrow of the mouse. For each iteration of the loop, it's calculated this frequency. And according to the step, and then it will generate a not events for the instrument 2. P7, it indicates, inside the algorithm, plays a key role, P7, because it indicates the number of segments, the number of iterations, and divide the amplitude for each segment. Here, divide the amplitude for each segment. Okay. As I said before, the graphic element has been realized in a unit square. With P7 we define the step that are inversely proportional to P7. One is referred to the length of the unit square divided by P7. Let's see the results. This is the 50 glissando. This is the example of the glissando, 50 glissando, the rendering. This is very basic sound, we can add other calculation inside the loop to make the sound more interesting. For example, we can reduce the duration. And progressive decrease the duration of the segment. For each iteration of the loop, the duration will be equal to itself minus the step. This is the result. How can you imagine this? The interesting aspect of this approach is that once you have created a model, you can explore a large number of possible alternatives of this model with simple operation. This is another example with the other 2 or 3 processes in the loop. In this case, the processes are deterministic, but it's not entirely predictable. Let's listen. Okay, now I'm going to, this is another algorithm is based on the construction lines of a Bezier curve. This example is in the paper. This is the spectrum. You know. So I'm going to show another example. One moment, please. These are two extracts of a piece that I realized with this technique. Let's listen. No, it's too extract. It's only two. You can see in these algorithms has been implemented, has been used to make additive synthesis. On the oscillator used in instrument 2, we can apply whatever synthesis technique, like FM, AM, or granular, for example. Or we can use the oscillator to control a filter bank or chorus. We know what can we do with a sine oscillator. I enjoy working with this kind of program, and it's really interesting. The the project now is still ongoing. Maybe my next steps will consist in developing a collection of Udo. I don't know. Okay, thank you.
Thank you very much, Simone.